Welcome to the Test Management Mindset, insights into the world of software testing. The best content by Practitest in audio form, designed to keep you inspired wherever you are. In today's episode, we are on the topic of smoke to avoid fire. Ashok Kumar explains how early-stage, high-level testing, smoke testing, can prevent downstream quality disasters. Learn how to spot red flags before they become critical issues and build a more resilient QA strategy. Let's get started.
Okay, so imagine this. You're deep into a really important project, things are moving along, and then bam, you hit a wall. You realize the very foundation, the thing everything else relies on, it's just not ready, not stable. Suddenly, all that progress stalls. It's, a massive waste of time, potentially worse. Today, we're diving into a concept that's designed to stop exactly that from happening, especially in the super fast-paced world of software development. Let's get into it. We are talking about smoke testing. And our deep dive today, it pulls insights from this engineering leader at TransUnion, the big global credit bureau. This person has 2 decades in QA and engineering, so tons of experience. Their talk was called Smoke to Avoid Fire, which is pretty apt, I think. It's full of really practical advice on building good smoke tests and, crucially, getting control over test environments.
Yeah, and if you step back for a second, it's not just a software thing, is it? Fundamentally, it's about checking readiness, validating stability really, really early on. That principle applies everywhere, in work, even just life projects. It stops small things becoming huge problems later. And it's amazing how quickly, tiny little foundational issues can just, derail everything if you don't catch them right away.
Absolutely. So our mission for you today is basically this. We want to pull out the absolute core of what smoke testing is. Why it's so important, looking at it from the wider industry view and from this specific insider team's perspective. We'll also look at the common traps people fall into and how this team at TransUnion actually navigated those. Think of it as maybe a shortcut, a way to help you ensure stability and stop wasting effort. You should walk away with some really clear ideas for making any systems really, more robust, more efficient. Okay, let's kick off with this analogy they used, which I found pretty helpful. Imagine there's a banner, stretched across the road just before you get to a big bridge. That banner, that's your smoke test process. The bridge itself, that's the whole test execution lifecycle.
Okay, I see where this is going.
Right, so if your process passes under the banner, no problem. You're clear to cross the bridge. But if you hit the banner, that's your warning sign. It's okay. You haven't actually hit the bridge yet.
You've got time.
Exactly. You've got that crucial time to swerve, fix the problem before you get properly stuck on the main bridge. So what's that really telling us about stability?
Well, it shows smoke testing is that first really quick check, like a preliminary look. They call it smoke testing, kind of like looking for smoke to see if there might be a fire starting, right? It basically just pokes the application, the system, to see if its most vital parts are stable enough to even proceed. Why is that so crucial? Because it's that super early warning. It stops tiny glitches becoming, total meltdowns, like a smoke detector, basically.
That's a perfect way to think about it, a smoke detector for your systems. Okay, let's dig into the need for this. Why is it so essential? Let's start with the industry view. And honestly, some of these stats are pretty eye-opening. So Gartner did a study. They found nearly 25% of test execution time is just gone, wasted.
Well, it's wasted. Why?
Because the test environments simply aren't ready. They're not stable enough to even start testing on.
Wow, 25%.
Yeah, and it gets backed up by Forrester. They found that for nearly 50% of the total test execution time, those environments are either completely unavailable or just fundamentally unstable.
That really paints a picture, doesn't it? Your testing capacity is basically kneecapped before you even start. But wait, there's more, and this is quite impactful. A Capgemini study. It showed that 60% of defects found during actual test execution. They were mostly just environmental stability problems.
60%. So problems that weren't even necessarily in the code itself, but the environment it was running in.
Exactly. Problems that, could have been caught and fixed way earlier if they had good smoke tests in place. And look at the flip side. 80% of teams said they had success with test automation only when their test environments were actually stable.
So it directly connects that foundational stability to being able to automate effectively. Makes sense.
It really does.
Okay, so that's the big picture. But what about the insider view? This specific team at TransUnion, why did they really push for smoke testing? Well, their main goals were pretty clear. First, just monitor environment stability constantly. Second, catch issues proactively, like before they exploded. And third, manage their testing capacity, better stop wasting that time we just talked about.
Makes sense. Sensible goals.
And also, crucially, especially because they were moving towards agile with developers checking in code all the time, they needed a safety net, something to give developers really fast feedback if a check-in accidentally broke something fundamental, that continuous loop.
Right, that quick feedback is key in Agile. So what about their technical setup? How did they actually build this? What's interesting here is they didn't get bogged down trying to build some super complex, bespoke automation framework just for smoke tests.
So what did they focus on?
Identifying the right checks, the absolute critical things that needed to be verified. Simple, atomic checks. Their setup used Jenkins' pretty standard automation server with master nodes controlling multiple agent nodes. But here's the clever bit. They built agent monitoring scripts. These didn't just tell them if an agent went down.
Don't tell me. They restarted it.
Exactly. They could automatically restart the agent, a genuine form of auto-healing built right in. Pretty neat for keeping the test infrastructure itself stable.
That is clever. Okay, and you mentioned speed is critical. How did they tackle that? They built in parallelism. So multiple agents could run under one master Jenkins node. Fine. But within each agent, they could run multiple executor threads at the same time.
So they could fire off lots of these small checks all at once.
Precisely. Spawn lots of smoke check jobs in parallel across the agents and threads, which meant super fast feedback, which, as we keep saying, is the name of the game here.
Okay, sounds like a solid plan. But, things never go perfectly smoothly. Did they hit any snags, any common pitfalls? They absolutely did. The first one they mentioned was bloated checks.
Bloated checks, meaning?
Meaning the smoke tests were trying to do way too much. Instead of just checking, is this service up?
Yeah.
They were trying to test like full functional logic or even regression test bits.
Okay. And the problem with that is?
Speed. It just slowed everything down massively. If your smoke test takes 30 minutes, it completely defeats the purpose of getting quick feedback after every check-in. They really needed those checks to be atomic, laser-focused on one single critical thing. Is the database connection alive? Yes, no. Done.
Yeah.
Not, testing a whole user journey.
Right. Keep it simple, keep it fast. Makes sense. What else tripped them up? Well, another challenge was putting too much focus just on the UI layer, checking if buttons looked right or whatever.
Okay, why is that a problem? Seems intuitive to check the UI.
It seems intuitive, but UI checks are, well, they're often heavy. They take longer to run. That slows things down again. And maybe more importantly, they can be really fragile, brittle. A tiny, unrelated change somewhere else might break the UI test, even if the underlying service is fine.
So you get false alarms. Or maybe false negatives where the UI looks okay, but a critical service underneath is actually down.
Exactly. Lots of noise. Wasted investigation time. They realized they needed to focus more on the deeper layers, the services, the databases.
Right. Check the foundations directly. So faced with these challenges, particularly the bloated checks, they had a choice, right? Build a totally new, lean framework just for smoke tests, or try and adapt the one they already used for their bigger regression tests.
They did, and they chose to adapt their existing regression framework.
Interesting. Why not build something new and perfectly tailored?
Pragmatism, really. They wanted to avoid over-engineering it, which always takes time. By reusing and adapting, they could get started much faster and start seeing the benefits, like right away. Sometimes good enough now is better than perfect later.
That's a really important point in development, isn't it? Don't let the perfect be the enemy of the good, especially when speed matters.
For sure. And even with that pragmatic approach, they still hit infrastructure issues. Like sometimes this smoked tests would fail, but it wasn't the application that was broken. It was their own testing infrastructure. The Jenkins agents were failing.
So the smoke test itself was unreliable sometimes.
Yeah. And that's actually what directly led them to build those auto-healing monitoring scripts we talked about earlier. They turned that infrastructure problem into a way to make the whole system more resilient.
So there's this constant balancing act, it sounds like. You need enough coverage in your smoke test to be meaningful, but you absolutely have to prioritize the speed of feedback.
That's the core tension, isn't it? And for smoke testing, speed always wins. It's not about deep testing. It's about that quick, is it basically alive? Check.
Okay, so they built this system, tackled the pitfalls, focused on speed. What were the results? Did it actually work?
It seems like it really did. Their setup could smoke check 21 different applications across different technologies, mind you, using just 40 of those focused atomic checks. And the total time to run all those checks across 3 separate environments, SIT, UAT, and even production.
How long?
Just 9 minutes.
9 minutes for 21 apps across 3 environments. That's pretty fast.
Right. And in the early days, they logged about 33 defects just from these smoke tests. All of them were environmental issues, the kind of stuff that could have totally derailed testing later if they hadn't caught it early.
That's a clear win. So 9 minutes is good. But are they stopping there? What's next for them? Well, one thing is better visibility. They're looking at building centralized dashboards, maybe using something like Grafana. The idea is to give all the stakeholders, developers, testers, managers, a single, clear, real-time view of environment health across the board.
Ah, that makes sense. If everyone can see the status easily, problems get flagged and fixed even faster. That visualization piece is often underestimated.
Definitely. And here's something really interesting they're exploring.
Oh.
Using machine learning. They're experimenting with ML models to try and predict which specific checks should be included in a smoke run, based on like what code was just checked in and what parts of the system that code usually impacts based on historical data.
Whoa. Okay. So getting smarter about which smoke tests to run to make it even more targeted and maybe even faster?
Exactly. It's about continuously optimizing. And speaking of optimization, they're always looking at their existing checks too. Can they make them even leaner? More atomic. They want to get that 9-minute runtime down even further. The next target is 6 minutes.
6 minutes. Wow. So for them, it really sounds like the absolute key metric, the North Star for smoke testing, is just raw execution time.
Absolutely. Speed, speed, speed. The faster you get that feedback loop turning, the more valuable the whole process is. Ideally, you hit commit, and almost instantly you know if you broke something fundamental. In their view, you basically can't be too fast as long as you're actually checking the critical things you need to check.
Okay, so let's wrap this up. What's the big takeaway here for everyone listening? This whole deep dive, it really shows that being proactive, monitoring things early, detecting instability right away isn't just like a technical chore. It's actually a strategic move. It saves huge amounts of time, tons of resources, and ultimately ensures things are stable and efficient. That applies way beyond just software, right?
Totally. If you zoom out, it's just a powerful reminder that investing a little effort in making sure the foundations are solid, it pays off massively down the road, exponentially sometimes. It's all about building that safety net, like we said, and really embracing that fast, continuous feedback.
And we saw how the TransUnion team did it, focusing laser-like on identifying the right small atomic checks, obsessing over speed, and cleverly building in that auto-healing to make the system itself resilient.
Yeah, which leads to, I think, a really practical question for you, the listener, to mull over. How could you apply these core principles? Prioritizing speed, ensuring checks are atomic and focused, building in self-correction where possible to whatever you work on. Even if it's not software, what are the foundational smoke tests you could implement in your world to check readiness early and, well, avoid those bigger fires later on?
That's a great question to leave people with. Thank you so much for joining us on this deep dive into smoke testing. We really hope you found it useful and maybe feel a bit inspired to apply some of these ideas.